Today we're going to continue with graphing linear equations. Today is going to be a little more challenging though because we're not going to be graphing discrete functions. We're going to be graphing continuous functions. And so you're going to have to really pay attention to a lot of different aspects. So please make sure you're focused and ready. All right, at the top, this is super easy. It basically says which ordered pair is a solution to this equation. When they ask a question like this, y'all know that in an ordered pair, it's always an x, comma, y. Yes? So if they give you an ordered pair and ask if it's a solution, you can simply plug this number in for x and this number for y and see if it's true or false. So if you look at this one, if I plug -2 in for x and 1 in for y, I would see if it's true or not. So I would just use my calculator, and I would say 4 times x. Well, 4 times, what is the value of x in this first one? -2, and then what's next? Minus y, so minus, what is y? 1 is equal to, is that equal to 6? So this is a no. All right, let's try this one. We're going to plug in 1 for x and -2 for y. So I'm going to do 4 times x. So 4 times x is 1 minus y. So what is minus -2? Plus 2. If it's a minus negative, change, it becomes plus. Or you could just put minus -2. The calculator knows that means plus 2. Okay, is that equal to 6? Yes. So this one's a yes, so I would circle it. That's the ordered pair that's a solution. A solution means it falls on that line. So because it's true, it's going to fall on that line. All right, let's try this one. 4 times x, which is 2, minus -2. Is that equal to 6? No. And then this one, 4 times -1 minus -2, is that equal to -6? No. So are y'all good with how to check those? All right, let's do this one. It says, is this coordinate a solution of this function? So you're simply going to plug in the 4 for x and -1/2 for y. So I'm going to say is x, so which is 4, plus 2 times y. What is y? -1/2, which I changed it to a decimal because it's easier to put it in. Is that equal to 5? No, it's equal to 3, and 3 does not equal 5, so no, this is not a solution. All right, let's check this next one. So -2 times x, which is -1, plus y plus -5, is that equal to -3? Yes, -3 does equal -3, so the answer is yes. This coordinate would fall on that line. It is a solution. Okay, do y'all have any questions on how to see if a number or if a coordinate is a solution? Now we're going to get into our graphing, okay? So yesterday, remember how we were given a specific domain? Today, you're either going to be giving something specific to do or you're not going to be given anything at all. Okay, so I'm going to talk to you about what to do in each situation. This says graph and give the range of this equation. Did they specify what the domain is? They didn't. So we're going to just make a table. Okay? If they didn't specify what the domain is, what do y'all think that the domain is going to be? Any number that exists. Yes? Okay. I am going to put numbers that would fit on this graph. Yes? What would fit on this graph? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way from positive 10 to negative 10. I don't have to do all of them. I'm going to do a few negatives and a few positives. So I'll start with negative 2. I'll do negative 1, 0, 1, and 2. And that gives me a good spectrum of both sides of the graph. So we're going to go to y equals. We're going to type this function in, so 2x minus 3. We're going to go to our table, and we're going to fill in our table based off of this domain. So when x is negative 2, y is negative 7. And now we're going to put those points on our coordinate plane. Now, will I connect the dots? Yes. They did not give me a domain that I have to specifically graph. So this graph is going to keep going forever and ever and ever. Do y'all agree? So I'm going to draw a line through these dots. Now, when you do this, listen carefully. Your line should go through the graph, slightly above and below with an arrow showing that it's going to keep going forever and ever and ever. Now it wants you to tell them the range. All real numbers. It's going to keep going forever and ever. The domain and the range are both all real numbers. Okay, let's do this one. It says graph and give me the range of 2x plus y equals 2. First of all, what do y'all notice about this equation? Is it in the form where I can put it in my calculator? No. What form does it have to be in to go into my calculator? Has to say y equals. So do y'all remember a few weeks ago when I was teaching y'all how to rearrange equations, I said this is super, super important, because if you can't rearrange an equation, you can't put it into your calculator. So the first thing we're going to have to do is rearrange this. So write that down. You're going to rearrange to y equals. So how would I get this y by itself? Subtract 2x from both sides. So I would have y equals negative 2x plus 2. Now I can make a table. Did they specify a domain for me to use? So can I pick it? Now what I pick obviously needs to fit on this graph, right? Because it would be stupid for me to pick 30, 40, 50 when that doesn't even fit on this graph. Even though it would technically work, I need it to fit on my canvas, my coordinate plane, my window of what I see. So we're going to go to y equals. We're going to type in negative 2x plus 2. We're going to go to our table. And if you want, go from negative 2 to positive 2 again. So negative 2, negative 1, 0, 1, and 2. And then go graph it. Would I connect the dots here? Yes, because it's going to keep going forever. So I must have arrows in both directions. Remember, your line should go through the entire graph, both directions, slightly with arrows at the end. And the arrows have to be there to show that it's going to keep going forever. Okay. Let's go to the next one. Oh, we didn't identify the range. It said give me the range. What is the range? It's going to keep going up and down forever, right? All real numbers. All right, look at this next equation. This one's interesting. Y equals 2. Is that an equation? Yes. Why is it an equation? Because it has an equal sign. What does that mean? That means it does not matter what x is, y will always be 2. So I can make a table. It does not matter what x is, y will always be 2. So I can do the same domain, -2, -1, 0, 1, 2. And it's saying it does not matter what x is, y will always be 2. Okay, so let's go graph that. Will this be arrows on both ways? It's going to keep going forever, right? Yep. Now, let's talk about the range. What does range mean? How high or how low it goes, right? What is the range here? What is y always? The range is y equals 2. That is your range. The domain, left to right, is all real numbers because it's going to keep going left and right forever. But the range is 2. Are we okay? Now, what if it is a little bit different and the next equation, instead of y equals, it's x equals? That means it doesn't matter. X will always be what? So if I make a table, x will always be -1. There's nothing you can do about it. It's telling you in the equation, x will always be -1. So you pick whatever you want the y's to be. X will always be what? -1. There is a trick to graphing these, and I'm going to teach all that. If it says y equals a number, like with no x involved, y equals 5 or y equals 6, it will be a straight line passing through the y-axis at that number. So everybody look, y equals 2, was it a straight line passing through the y-axis at 2? If it says x equals a number with no y involved, it will be a straight line passing through the x-axis at -1. So is this a straight line passing through the x-axis at -1? Yes, now stop. We didn't identify the range. What does range mean? Highest to Is it going to stop? All real numbers. Now we're going to get into the ones that are a little more tricky. So do y'all remember when y'all were learning to identify domain and range? And I taught y'all line segments and rays. Yes or no? Okay. So if it has, write this at the top of your paper. Actually, we still have one. Do we need to do one more that has arrows going all the way through, or y'all okay? Do we need to do another one of these? Y'all got it? Okay. So let's skip this one. All right, let's go to this one. And I want you to write this. If it has one stipulation, like one rule, make a ray. An array looks like this. If it has one stipulation in the domain, like an inequality, but not with the two numbers, just the one number, make a ray. So they want us to graph this function. But they're very specific about the domain. Look at the domain. So do y'all see how they specified on this one what the domain was? But they didn't specify individual numbers. They didn't say the domain is 0, 1, 2, 3. They said the domain is anything greater than or equal to 0. Does that make sense? So your spot is going to be where x is 0. That's going to be this dot right here, where x is 0. And then it's greater than or equal to. So then we're going to figure out which way to go. Okay, so here's how you're going to do it. You're going to make your table. This is the most important part. You need to listen to this part. You don't get to pick these numbers this time. This picks them. What is it telling you to start with? 0. And then from there, are we going to go up or down? Up, because it's greater. So I'm going to have 0, then I'm going to have 1, 2, 3, 4, whatever you want. You could keep going, you could go less or more, whatever. So I'm going to go to my y equals button and figure out what those are. I'm going to go to my table. Ooh, do y'all see what, when x is 1, y is what? Do I have to graph that? Can I skip it? I only need like 3 dots, so I'm not even going to put that. When x is 2, y is 3. When x is 3, it's a fraction. I'm not going to do that one. When x is 4, y is 2. Oh, and I'm going to do another one. Let's see. When x is 6, y is 1. And when it's 8, it's 0. Yes, these points fall on that, don't they? But you don't have to graph them if they're crazy decimals. Skip it. Now, where did I say your dot was going to be? Where x is to 0. So right here, circle that. That is where your dot is going to be, and it's going to be a solid dot because it's equal. Yes? So go put that dot first. So everybody go to 0, 4. And that is going to be your big solid dot. Your ray is going to start right there. Because a lot of people will graph all their dots and then they don't know where the ray is going. So my ray is going to start here and my arrow is going to go away from that dot. Okay? So now go graph 2, 3, 4, 2, 6, 1, and 8, 0. Am I stopping at 8, 0 or does my ray keep going? It's going to keep going. But I know my pencil's going to start here and my ray is going to go this way with my arrow coming down. Because here's where students have issues. they graph it, and then they think the ray is going to go this way. No, it has to start here. Make sense? So I start there, and my ray looks like this. That's why I told y'all graph this spot first, and just remember that's where you're going to start your ray. Now it says, identify the range. What does range mean? Lowest to, so this has a highest point right here. Where am I at? On the y-axis. So y is it going up or down from there? So less than or equal to 4. That's my range. Okay, let's do this one. Here is my function. And then they gave me a very specific domain. So when I make my table, what do I have to start with for my x's? I have to start with 0. Now, I'm not going to go pick because there might be fractions again. I'm not going to go pick what's going to go, but which way am I going to go? It says x is less than or equal to 0. So from 0, where am I going to go? Down. I have to go into the negatives. I don't get to go up because it's telling me it's less than. So I'm going to go to y equals, and I'm going to type in negative 5x plus 3. Okay, let's go to the table. When x is 0, what is y? 3. Now my next dot has to be less than that. So I have to go that way. Does that make sense? So I'm going to do when x is negative 1, y is 8. When x is negative 2, y is 13. I don't think any more will fit on this graph. So I'm just going to stop. Now, where's my big dot for my ray going to go? Right here. This is my starting point for my ray. This is where my big dot's going to go. That way you know where to start your ray. Okay? So go graph 0, 3. Put a big dot right there so you know that's where you're starting your ray. Then go graph negative 1, 8. Will my other dot even fit? No, but I have 2 dots, I'm good. So now I'm going to connect them, but where does my ray start? Right here. And then my arrow goes to the other dot. Make sure you have that arrow going through. Now let's identify the range. What does range mean? Lowest to highest. What is the lowest this dot goes on the y-axis? 3. Everything else is going above it. So y is it greater than or less than 3? Greater than or equal to 3. Now, how did I know those were rays? Because they had one stipulation. Look at the next one. How many stipulations are there? 2. This is where you know to make a line segment. So write this right up here. If there's 2 stipulations, make a line segment. What is a line segment? A dot connected to a dot, meaning there will be no arrows. If you put arrows on these, the graph will be wrong. Okay, here's our function. Here's our stipulation. Let's make a table. What are they telling us our domain has to be? That it's going to be between -1 and, so I have to have -1 and I have to have 3. And everything in between. I don't have to have dots for everything in between, but I'm going to connect it between those, right? So I have to have -1 and I have to have 3. You can put whatever you want in the middle, as long as it's between -1 and 3. You don't have to put every single dot. You can, you don't have to. So I could put -1, 0, 1, 2, 3 would have been right here. So there's going to be a dot here and here, and then it's going to be connected between them. Yes? All right, let's go to y equals. My function is -x minus 1. Now go graph it. Again, this is not going to get any arrows. This dot is going to get connected to this dot. Did I even really need to put those dots in between? No, what I have to do is connect it between. We need to identify the range. What does range mean? Highest to, all right, so the range is, what is the highest on the y-axis this is going? 0. What is the lowest on the y-axis this is going? -4. And y is everything between. Okay, go to the next page. This is a typo up here. Cross this function out. We're going to change it. It's the same one we just did. So we're going to change this equation to y equals 2x plus 5. All right, so look at the stipulation. How many are there? So is it going to be an array or a segment? Segment. All right, let's make our table. What does my domain have to go from? -1 to 3. Okay, y'all try the rest on your own. Let's see how you do. Once you've graphed it, check it with mine, but don't forget to identify the range. How did we do? Good? Do y'all want to do another one? Are y'all sure? Okay, let's do just one of these to make sure y'all are good. Because if the function is not set up for y, you have to do what? You have to solve for y first. So let's just do this one. If I need to solve for y, what's got to go? So minus 2x on both sides. I have 3y equals negative 2x plus 9. And then how would I get rid of the 3? Divide everything by 3 and then simplify. So I have y equals negative 2/3 x plus 3. Okay, on 1 through 3, you're picking A or B. Which one satisfies the equation? Which one of these would work for that equation? For 4 through 9, you're just solving for y. So you want them to look like y equals mx plus p. Yes? On 10 through 15, all they want you to do is graph the equation. Did they specify the domain? No. So these will be lines with arrows going both ways, because they did not specify. You will have to rearrange these for y. Do y'all see them? They're not in y equals. Remember, for 13 and 14, I did an example with you in your notes, so you can always refer to those to see. Now, for 16 and 17, there's multiple parts. You're going to graph the function with the given domain, then identify the range. So please make sure at the bottom you are identifying the range just like we did in our notes. Same thing on 18 and 19. Make sure that you're identifying that range at the bottom. Don't forget to do that part. You are going to do 20 through 23, and then 24 will be extra credit if you can figure it out. Make sure you are answering every part of a word problem, though. Okay?